Okay, welcome back, everyone. My name is Amanda Ostwald. I'm a PhD candidate at the University of Nevada, Las Vegas, and I'll be chairing our final presentation session for the day on guiding principles and exploration strategies. I'm excited to present our first speaker for the session, Jennifer Heldmann, who will be talking to us about how we can optimize the scientific productivity during Artemis. So take it when you're ready. Thank you.
Okay, great. Well, thank you. It's a pleasure to be here with everyone today. This has been a very informative meeting so far. So I just wanted to go over from the team some guiding principles to optimize science productivity during Artemis when we're at the moon. So I just want to acknowledge the co-authors who have all contributed to this. A group from NASA Ames Research Center, colleagues Darlene Lim, Tony Coldebreit, Rick Elphick, Dave Lees, Alex Selke, and Zara Nurmalik. Also, the group at MIT, David Newman and Julie Shaw, and also her graduate students. We're going to talk about some of their work in this presentation, and it's really important to keep the grad students involved, as we've talked about before. Chris Zachney from Honeybee, Josh Coyen from USGS, and also Anna Wagner from the US Army and CREL. That's a Cold Regions Research Environmental Lab. Next slide. Okay. We've talked about this already a lot today, but there are a lot of elements that need to be organized within these missions, and there has to be a lot of coordination between these multiple program elements. So, of course, the astronaut team, that crew on the surface, the Artemis Science Center. This is something that's come up earlier today. It has been called a back room in the past. I'm going to suggest we call it something like a science center. Jack and Jim Head were saying this morning during Apollo, it was the SRR, the Science Support Room. And the Viper mission, it's a mission science center. And the Artemis SDT report, it's a science mission center. Something along the lines to convey the importance of this activity. I know that right now we're all excited and we're integrating science and exploration. But in case we don't have the budgets that allow this work, and if hard decisions have to be made when Artemis is going forward, calling it a back room may not convey the criticality of this function. So the Science Center, the flight ops, the ground data systems, the tools, sampling, software, all these parts need to be worked together. If we go to the next slide, we would advocate that science needs to be integrated with each facet supporting these lunar operations at the earliest opportunity. And the reason is because architectural or programmatic decision in one area can often have significant and at times unrecognized impacts to other program areas, including science, and we want to avoid that. So we need to make sure these decisions are made with science at the table at the earliest stages to mitigate against these inadvertent negative consequences to the scientific output of the missions. Next slide. Crew training, we've talked a lot about this already. Artemis crew must be trained in field geology at the earliest opportunity, and I think Jack really hammered that point home earlier today. We need a strong background in lunar science as well as the field science to increase the robustness of the astronaut decision-making in the field. I think David Kring made a comment in the chat earlier that a well-trained astronaut in the field is your best tool, right? So we need to train them in the science background, the rationale, the field operations, and also the post-mission data analysis. So our teams have done a lot of work bringing astronauts into the field to do field science. An important part of that is the work does not end once you leave the field. Integrating the astronauts into the post-field work analysis, the lab analysis, the sample analysis really helps to instill in them the importance of getting the right samples and how to do that and gets them invested. So I think that's important for the astronauts. And then also a point that Deva and her team made from MIT, the crew should be fluent in technology advances, in automation and data to optimize productivity on the lunar surface, right? Since Apollo, there have been tremendous advances in technologies that we can utilize on the lunar surface. And so that's something I think maybe we can talk about in the breakouts is how do we integrate those technologies into what will be Artemis surface operations. Next slide. Okay, an important point is the ground data systems and visualization. So we have this science center because these folks can synthesize huge amounts of data much more rapidly than the astronauts. We'll have more people in the science center. We have extensive career training of the scientists. That's what we've been doing for our lifetimes. Dedicated analysis time and more capable analysis tools. So in order to add value to the execution of those EVAs, including both the real-time EVA support and then the replanning and planning for future EVAs based on previous data, we have to have sufficient situational awareness through the return of appropriate types and volumes of data to the lunar surface. And this is a non-trivial issue that I think we need to address early. The Science Center has to have that data available and displayed in meaningful ways. We can't just have a dump of data and then just expect to use it. How do we visualize it? How do we interpret it? What processing needs to happen so we can use it in real time? We need that so we can support both tactical and strategic operations. And so this puts requirements on the ground data systems for how that data comes back and how it's processed and how it's displayed. So this is something that I think needs to be attacked early in the program. Next slide. I think that was the last slide. Can we go the other way? There we go. Thank you. Okay. And along these lines, in talking about advanced technologies that could be used, one example for visualization is advanced tools such as augmented reality, virtual reality, etc. Might be useful for meeting the visualization and capability needs of the Science Center. And so I think in the breakouts, I'm going to put Ferris Ward on the spot. He's one of the facilitators for this workshop. He's also one of the grad students at MIT. I saw Cody Page was on, Lindsay Sandeman was on. These are the grad students who are developing these tools, like virtual mission control tools to visualize the data and give 3D representations, laying your spectral data over topographic maps and having you be immersed in that so that you can really get in and analyze that data. And they're doing the back-end processing so you can get, go from your squiggly lines of your spectra into beautiful maps that you can then interpret right away. So these are the sorts of things that are being developed, and hopefully we can get into some of that during the breakouts. Another really important point is that the EVA timeline planning and scheduling tools must be accessible to the people in the Science Center. And that is not only to accurately follow the timeline activities for what's planned, for what the astronauts are doing, but we need to have the information if we're going to revise those plans. We need to be able to manipulate those schedules, be able to play with it, see what's going to go where, what's going to fit when we change the field plan based on the science knowledge that we learned on the ground. So the teams need to be able to have that capability in the Science Center to do that. Next slide. This, I think, will also be talked about in the breakouts, and we've talked about it a lot already today, how the Science Center would be organized. We clearly must either include explicitly or have access to personnel with expertise regarding each of the scientific instruments that are collecting the data on the moon. There will be nuances, there will be details, there will be changes that are made based on the instruments. There will be off-nominal measurements that are returned. There will be gain settings that need to be changed. There will be unique and interesting data interpretations that are specific to each instrument. We have to have that expertise. We also have to have leads for both the tactical and the strategic planning and how that's integrated during flight operations. I think the next bullet is something we'll talk about and some ideas that have already been put forward in this meeting, but a streamlined communications architecture from what's happening in the Science Center and then up to the flight director, to Capcom, to take all the analysis that's going in the Science Center and synthesize that into a concise, pithy summary that can be translated into tactical operations for the astronauts on the surface. And in order to do that, we are recommending a dedicated science lead console position for this. And hopefully we can get into some of the details of where that science lead actually lives and where that communication line goes from that science lead. But you need someone to integrate all of that information. Let's see, let's go to the next slide. Decision-making protocols. So the Artemis program must clearly delineate the responsibilities and protocols regarding decisions affecting the planned crewed EVAs. So I think most of the people, we are in this meeting because we appreciate that there will be new and unanticipated discoveries. This is why we need a science and mission support center, right? So we need to be able to prompt a change in that. I thought it was interesting in the shuttle and ISS EVA talk, saying that EVAs are planned to the minute, and that is not how Artemis will work. So we should be aware of the giant paradigm change from how we're doing it now to how we're going to need to do this for Artemis. And, we talked about earlier today about how that worked on Apollo, and Jack was saying how the changing of EVAs actually worked pretty well. So we've got to maintain that flexibility. And I think that's something we have to continue to harbor that point across all these different facets of the Artemis program. The ability for science to recommend these changes has to be expected and embraced. We have to make it possible. And when the rubber hits the road and you want to change an EVA plan, get that through flight systems, it sounds great in theory, and we just need to make sure that we still maintain that capability. And we have to outline when and where we can do such changes. And I think if you just go to the last slide, because I see the time is up. Second to last slide. We'll talk about this too. Analog testing and simulations, test. And this is beneficial not only for the science, but also surface tool development. And so Chris Zachney, who's done a lot of tool development, has made the point that astronauts shouldn't just test tools in the field after they've already been developed, but we should have them integrated during the testing to provide feedback on the design and the tool functionality. So keep them involved in the whole process, not just at the end. And then we have to integrate the science, operations, and technology in a sequence program to train the crew and also all the staff that will be happening it, which also includes the science team. And an important point is these field activities should include non-simulated science, right? We have to do real science. We can't just, pick up rocks and dump them on the road and then go home, right? We have to bring those back. We have to get, science papers out of them. We need to have PhD students that are dependent on this data from this field campaign for their, for their thesis, because it increases the robustness and the fidelity of the work and of the findings that you get, because it's the real deal. And that's what we're going to need to do on the moon too. Next slide. I'll just end with this. We've talked about this. We want this exploration of the moon and onto Mars to be a sustained effort. So we need to train the next generation of scientists and engineers and operators, et cetera, so we can have this long-term program. And while we're doing that, it would probably behoove us to intentionally focus on diversity, equity, and inclusion, because we need our technical workforce to capitalize on the talents of the full spectrum of society to maximize our productivity and innovation for this sustained exploration program. And so with that, I think the last slide, just say, let's just go and looking forward to actually doing it, boots on the moon.
Thank you so much.